Hi, in this video I'll be demonstrating how to connect an additional zone to your alarm system. This happens to be an IDS alarm system, but the principles I'm going to demonstrate remain true for other alarm systems as well. In this video I'll be demonstrating how to connect a regular door contactor, an indoor PIR. I've got two different types. I'll show you both, an outdoor PIR and then a beam. Now this is the main board of this particular alarm system, and as you can see it says zone 1, zone 2, 3 all the way up to 8. I'll demonstrate how to add an additional zone. I will do zone 1 and 2. First thing you'll need to do is have a flat screwdriver and open up those terminals. On zone 1 I'm going to connect a door contactor. Now over here I've got the door contactors. You'll see there's a brown one and a white one. These come in different colors. I've just got the brown one here for display. I'm now going to connect this door contactor. Now what you'll notice is one of these is a magnet and one of these is a reed relay. I'll open up the one that you need to wire. I gently put my screwdriver here in the side and then there on that side over there. Then I flip it around and I just push my screwdriver over at the back, and there you can see it is opening up. Right, here is my door contactor. All I need to do is open these two screws. Right, now I need to wire it to the zone. I've got two different types of cable here. They are different in color and in type. The one is stranded cable and the one is solid cable. Both will work. It's recommended to rather use wire strippers than side cutters. I now need to expose the cable. For the door contact, I'm just going to use two colors. I'm going to use white and blue. Now I need to expose the copper. Expose no more than 10 millimeters of the copper. Twist the copper in your fingers. Now install this into the terminals and then tighten it. When looking closely, you can see that the screw depresses onto the copper and not onto the jacket. That is why you can see the copper slightly here on the edge of the terminal. If you cannot see the copper wire here, then just make sure you have not tightened the contactor only onto the jacket. Now on the other side, I just need to connect it to my door contact. Now before I insert this here, it needs a series connected resistor. On this particular alarm system, it wants a 3K3 resistor. That means 3,300 ohms. The color profile of this resistor is orange, orange, red, gold. You can see on my meter it is almost 3,300 ohms. These resistors come in different wattages. The most common type for your alarm system is a 1/4 watt. Now I recommend that you cut a bit of the resistor leg off. Expose a bit more of the copper on the one wire. Twist the resistor and the wire from your alarm system. If you want to make sure this never has a problem and does not oxidize, use a soldering iron and solder this. It, however, is not mandatory to solder it. You now need to connect that under that screw and that under that screw. It does not matter which order you put it because this is unidirectional. When you tighten the screw by the resistor, do not tighten it right onto the body of the resistor. There you can see I've left about 2 to 3 millimeters. You can also see that the contactor is tightened on the copper and not on the jacket. Now on the cover you'll have to decide, are you going to thread the wire that way, or are you going to thread the wire that way, or is it going to come out the side? If it's going to come out the side, you want to break this tab open. Since I do not need these additional wires, I can cut them off. Now I just seat that over like that and I can put the cover on. Because I'm threading the wire through the side, I'm going to break this cover over here. I now put my cover back on and depress it. I've now wired the door contactor. It goes with its magnet. It does not require power to operate. If you're going to be screwing these onto a door, you'll need to open them and use the screw holes, screw it into your wooden door frame or the wall and then close it. Now you may have noticed that the door contactor does not require a positive and negative. It literally only needs the wires coming out of the zone. For the next sensor, it's going to require a positive and a negative to activate the sensor. I now have two different PIRs from two different manufacturers. This is the IDS version, this is the Optex version called RX40. Alright, on the Optex one, there's a screw here. You just unscrew it, remove the screw, open up the sensor. Do not touch the infrared platform over there. Now in this case I'm going to use the brown cable. At the back of the unit you'll notice there's a punch hole over there. If your cable is going to be going through the wall, then you'll want to punch that out. There's another punch hole over there. If your cable is going to run in this crevice over here and go through there, and this is going to be flush on the wall, well then you'll punch it out there. I'm just going to show you the wiring now. Right, I'm going to remove this sponge now. Right, once you've opened the unit, you'll notice there's a positive, a negative, and then normally closed contact. So these are the 4 terminals which you'll be using. If you would like to, there is a tamper connection over here, which I will briefly explain. I'll first show you how to wire it up using the positive, negative, and the normally closed. Why it says normally closed, it means as soon as you power it up with the 12 volt DC, these contacts will become a short circuit. When the alarm activates or it loses power, it will open this circuit, sending a signal to your alarm system that there's trouble. Right, for this setup, I'm also going to use the blue and the white, but I also need a black and red for the power wires. I'm not going to be using these remaining wires. Right, I've now prepared the cable. I've got the sensor side and the panel side. This is going to be connected on the panel, and this is going to be connected at the sensor. I'm going to first start with the sensor. Now I recommend you use wire strippers to strip the copper, otherwise you may nick it. If you use side cutters, it's fine as long as you do not nick the copper. This is what happens when you nick the copper. You can see there I've stripped it, but if you look closely you'll see it's nicked. Right, so just over there it's nicked, and why that's a problem? Because look at this. Broken. It's actually broken off. If you want to, you can even just use your nail to pull the jacket off. Right, you can see I've removed the jacket, but what I want to bring to attention is look how long that is. That is almost 13 millimeters, and look at the little contacts here on this board. So when I insert this in here, you can see what's happened here. It's too long. So what I need to do is shorten these wires. This particular terminal is not very deep, so I need to shorten these because I do not want them to short out each other when they are connected in the terminal. The red wire in this case is the positive and goes where the positive sign is. The black wire is the negative and goes where the negative sign. Right, there are your positive and negative, and now it's time to wire your alarm connections. So now I need to add your series connected resistor. In this case, I'm going to add it to the white wire. It does not matter which wire you add it to. I've extended this copper a little bit, and now I twist the resistor leg and the copper together many times. If you have a soldering iron, you could solder this. It is not mandatory to solder it though. And now insert the resistor into the terminal. Note that I leave a gap between where the resistor body and the terminal meet. And now insert the other alarm wire. Right, those are the correct connections for the PIR without the tamper connected. I'll now show you how to connect this to your alarm panel. I'm first going to connect the alarm wires. Remember I used the white and blue. Well, now the white and the blue need to be connected to the zone which you would like to add. In this case, I'm going to be adding it to zone 2. I insert the wire into the number 2 over there. Now on this particular alarm system, you'll notice that the middle wire is actually shared. So there you can see it says 1 dash. Then it says 2. So 2 is correct, but now you can see the dash here is for both zone 1 and zone 2. So I'm now going to open zone 1's blue wire. I'm going to remove it. And I'm going to join these two together now. While I'm joining these, I just want to show you this is a solid core cable and this is a stranded. Both are suitable for alarm systems. Right, I now insert the joined wire into zone 2. Right, to recap, on zone 1 I had a door contactor and there it is. On zone 2 I now have my PIR for an indoor sensor. There you can see the wires for zone 2. The last thing I need to do is power up the PIR. That is what the red and the black wire are for. On most alarm systems you'll see there's a 12 volt section available on your main board. In this case it's over here. I'll now connect the red wire to the positive and the black wire to the negative. So there you can see the positive wire over there, the negative over there, and then the corresponding alarm wires for that PIR on zone 2. So this passive infrared sensor is now connected. Now in this case, my passive infrared is connected. My alarm panel has been powered up from a battery. So that means my PIR is now getting power from this main board. If you have a look, if I move my hand, you'll see this LED is activating, telling me that it's sensing motion. Now just inspecting the PIR, if you have a look here, you'll see there are some jumpers. I'll just briefly explain what these two jumpers do. Now this jumper over here says LED on or off. Now as I move, the infrared sensor picks up my motion and you see the LED goes on. If you want to run the PIR in a covert manner, you can see that I'm moving. The sensor is working, but the LED is not going on. So that's a covert operation. And now when I replace the jumper, you can see the LED comes on. Now there's another jumper here and it says pulse count 2 or 4. This has got to do with the sensitivity of the PIR. As I move my hand, you will see that the LED will come on pretty quickly and stay on. You can see that it's staying on, it's activated. But if I remove this jumper here, it now needs to count 4 pulses, means it needs to pick up my motion 4 times before that LED stays on. So I'm going to stay still until the sensor has cleared its memory. So now I need to move twice as much. Now lastly, now there's a terminal here that says SP for spare. If you didn't like the way I did this, twisting the alarm wire onto the resistor, you can also use the spare terminal for that purpose. So what I've done is I've moved the resistor from that terminal to that terminal so it can act as a link between there and the spare terminal. So there comes my alarm wire coming in there, then there's the normally closed contact, and there goes the resistor to the spare. So now I need to connect the other zone wire to the leg of the resistor. So in this case, I've just used this terminal as a junction for the resistor and the zone wire. The spare terminal is not connected to anything, it's a floating terminal, but here I now have no wires exposed. Remember before I twisted the resistor wire and this white wire outside over here, but now I've just put it into the spare terminal. Now I'll just show you a different PIR, just in case you have to wire one that's slightly different. On this one, you can see that the circuitry is on the face, so it looks more complicated, but really it does the same thing. So your negative wires going there, there's your positive, so those are the wires that power up the unit. There's my normally closed contacts there and there. So you can see there comes my alarm wire, and then there's my resistor, and you can see that my resistor is connected to this terminal only as a junction. So what I've done here is I've used this terminal as a spare. If you find this confusing, you can just twist the wire outside. You don't have to use that additional terminal. Right, so there you can see I've taken it out of that terminal, and here is how it is connected. Now looking at this sensor, you can see there are additional jumpers here. This one says LED on or off. So if I remove this one, the LED will not operate when there's motion. Then there's another sensor here which says range. So on this particular PIR, you can actually determine if you wanted to be able to pick up motion further away or only close to the sensor. Some PIRs have a range function, some do not. Then over here, we've got the pulse count. On this one, you can say 2, 3, or 4. So this also sets the sensitivity of the PIR. Do you want it to alarm immediately, or do you want it to have to count more than one pulse? Meaning an intruder would have to move a few times or take a few steps before the PIR activates. Now the last thing I'm going to show you is something called tamper. Over there are 2 contacts and it says tamper. What tamper is, it's an additional alarm feature on most sensors that allows the alarm panel to know if somebody has tried to interfere with the casing of the sensor. For example, here is the cover of the sensor, and when you take it off, there is a limit switch here that changes state. There on the side of the cover, there's a raised section that mates with this limit switch over here. So when the cover is on, it closes that limit switch. When you open the cover, it opens that limit switch. Looking at my other sensor, this one uses a spring-driven push-button switch. As I put the cover on, it depresses the switch, closing the tamper circuit. So the cover is here, and on the cover there's a raised section which depresses the spring, and therefore it will close the tamper terminals. On this PIR, here are the tamper terminals. So when you depress the spring, the tamper terminals become a short circuit. So just quickly demonstrating it, there are the tamper terminals. Here is my meter set to continuity, which means if I have a short circuit, it will say 0 and you will hear the buzzer. Right, so there's the tamper. When I depress the spring, short circuit. And over here, same story. When I depress the limit switch, so you can wire in an additional alarm function telling your panel that somebody's interfered with the sensor and tried to open the sensor. This is a good feature, especially for beams. On sensors like these indoor PIRs, it's very uncommon to use the tamper feature because it's quite hard to open this cover without putting your hand over the sensor. But a beam, on the other hand, because it's so focused, you can open the cover without violating the beam. Therefore, on the beam, the tamper should be used. Right, over here, I've got the wiring diagram for a DSC alarm. And you can see that there's an additional resistor that is required to wire the tamper. Now, the resistance values on these panels is different to the other alarm panels. For example, this is an IDS alarm, and you can see it's got two different resistance values, a 12K and a 4K7, while the DSC uses a 5600 ohm and a 5600 ohm. So different alarms use different resistance values. And here's another layout. And this is also an IDS alarm, which then swaps these resistors around, once again changing the way the tamper is connected. Therefore, I'm not going to demonstrate the tamper because it is different for different panels. If you'd like to see how to connect the tamper for your PIR, please check my playlist, as I have a complete video just dealing with the topic of tamper. Right, now I'm going to move on to a different sensor. Right, now I'm keeping these wires as is because I'm now going to wire an outdoor passive. I now have an outdoor passive. This is an Optec sensor. It's called the FTN sensor. I'm going to use the same wires because the connection on the main board is exactly the same. So I'm leaving that the same way it was from the indoor PIR, and I've disconnected this from the indoor PIR, and I'm now going to wire it to the outdoor PIR. I just need to open the front cover. Now, on this particular sensor, there's a positive terminal, a negative terminal. There it says AL, this is alarm output, that's common. So those are your two alarm wires. This particular sensor also has a trouble output. Then it's got the tamper and the tamper. Remember I said the tamper is connected to the limit switch. If you want to connect the tamper, then you'll be using these two. I'll now quickly wire this in the most common layout. Right, for this outdoor passive, you can see I've got the positive, the negative, the alarm, and the common. So that is how you wire this in the most basic setup. On the alarm panel side, you get your positive from the positive, the negative from the negative terminal, and then whichever zone you've connected it to. Now, while I have this PIR open, I just want to show you there are these dip switches here, and these dip switches correlate to this diagram over here. So you can see that you can change the settings via these dip switches. You can switch off the LED, maybe you want it in covert mode as I showed with the indoor PIR. You can also change the sensitivity, you can make it less sensitive or you can make it standard. You can also change the contact here for alarm circuit to normally open, or you can leave it as normally closed. The most common one is normally closed. And then some PIRs have additional features, like this one has anti-masking. That is why it says FTN AM. And you can also switch that on or off. So different PIRs have different additional functions. But in this video, I was just showing you how to connect it as a zone. By the way, there is the limit switch for the tamper if you did want to wire the tamper on this sensor. On many outdoor PIRs, you can also adjust the sensitivity range in terms of how many meters the sensor will detect within. On this one, all I do is I take out this lens and you can flip it around. And now you can see it's only detecting up to 2 meters. Or if I flip it back, you can see it's now detecting up to 5 meters. So each sensor has its own peculiarities in terms of how to set it up. Right, I'll now show you how to wire your beams. Your beams are wired differently. I'm going to have both sets of beams open at the same time. Loosen the screw, you do not have to remove it completely, you just need to loosen it. Right, you'll notice that one of the beams says transmitter and one says receiver. That's very important in terms of how you wire this up. Because these are beams, there need to be 2 units. That means they'll have to face each other. When somebody gets in the way of the beam, it'll then send an alarm signal. Right, I'm first going to show you how to wire the receiver beam. Now at the back, you'll see a place where you can thread your wire or you can punch it here. And if your wire is running along the back, you'll have to cut out that point over there. Now on the top of the beam, you'll see your connection setup. 1 and 2 is power. Now it does not say which is positive and negative, so it does not matter. In most beams, it will say which is positive, so make sure you put the red wire on the positive terminal. Then it's showing you the alarm conditions. Normally open, normally closed, and common. I'll explain that shortly. Now it's also got a fault condition. You can also report a fault signal to your alarm if you want to use these terminals. Make sure all the terminals are open. Right, wire your positive and negative to your power terminals. Now we need to choose the normally open and normally closed and common connectors. Now, do you recall in the last sensors I said we are using normally closed? Most alarms rely on a normally closed setup. So in this case, I'm going to continue to use the normally closed option. Normally closed means I'm using terminal 4 and 3, so 3 and 4. So I just need to connect my resistor to the one wire and the other alarm output wire to the other. Right, there is the beam connected in its most simplest form. Now just a note regarding the normally closed and the common and the normally open connections. This means normally closed only once this is powered up. So as soon as you power it up, you'll see terminal 3 and 4 become a short circuit. When it alarms, it will become open circuit. If you use the normally open setup, what happens is only when it alarms will terminal 5 and 4 short out. In this case, we are using 3 and 4 because that is how our alarm is wired up. You want to say normally closed connection under normal conditions. Only under alarm conditions should it become an open circuit. Right, so this is now wired up, but we've got one more step. Because there are 2 units required, we need to give this unit a positive and negative so that it can transmit its transmitting signal. If you have a look at the transmitter, it's got 2 terminals and there it is, 1 and 2. So you also need to connect a positive and a negative to this transmitter. If you are going to be using the tamper function, just to show you, there's the limit switch on the transmitter and the receiver, and what happens is when you close the cover, it depresses this limit switch, shorting out the tamper terminals over here and over here. Right, over here you can see the receiver connected with a positive and negative, and then the alarm output. Over here you can see that the transmitter just needs its own power source. There is my positive and negative, and I've wired this directly from the alarm panel. If you have another alternative 12 volt supply, it's fine. The transmitting beam does not have to be fed from the same power supply as the receiver. Alright, thanks for watching and cheers.